Our next gas law that we are going to study is called Dalton's law. Now that name should sound familiar to you because we have heard of Dalton before. He was the one that came up with Dalton's atomic theory. So back when we were studying conservation of mass and the periodic table, we heard of Dalton. Same scientist who also came up with this gas law that we're going to study. Okay, so Dalton's law states that the total pressure of a mixture of gases is equal to the sum of the partial pressures of the individual gases. Okay, so what that means is that if you have a container with a mixture of gases inside of it, if you add the pressure of each individual gas, you will get the total pressure within the container. Okay, and using our algebra skills, if we know the total pressure of the container and we know the pressure of one of the gases, we can figure out the other gas. Okay, so here's your equation. You can go ahead and add this to that equation sheet that you have been developing throughout the semester. So your P total, this is your total pressure, is equal to the pressure of gas 1 plus the pressure of gas 2 plus the pressure of gas 3, and so on. So if you have 10 gases, you could have plus P2, plus P3, plus P4, and so on. So you can grow that for as many gases as you need, okay? Because we are just adding up those pressures. Now, what a lot of chemists do in real life is they will use a chemical equation that produces a gas that they need, and they collect that gas over water. They collect it by water displacement. So if we look at this experimental setup here, we have a container with zinc in it, and this is closed off so that it cannot escape this way. It can only go in one direction. And we add sulfuric acid because that chemical reaction creates hydrogen gas. Okay, so the hydrogen gas only has one way that it can escape. It has to come through this tube here. It goes into this water container and it bubbles because it is a gas. As it bubbles, it rises up into this area here. And so it pushes the liquid water out. And so you know that as this fills up, it's filling up with hydrogen gas. But what also happens is that some of the water vaporizes. So some of the water becomes gas as well. So the gas you have in this area is a mixture of the hydrogen gas that you're collecting as well as some water vapor gas. Okay, and so we need to use Dalton's law a lot of times for us to be able to determine how much gas we have produced. Okay, so let's look at an example problem. All right, so here's the word problem. Hydrogen gas is collected over water at 22.5 degrees Celsius. Find the pressure of the dry gas if the atmospheric pressure is 94.4 kilopascals. Okay, so what we need to know here is that atmospheric pressure is equal to the total pressure in the collection bottle. Okay, so if you're ever told the atmospheric pressure, that is equal to the total pressure in our equation. So let's analyze this word problem and figure out what do we know and what do we need to know. Okay, so it says we're using hydrogen gas, that's what we're collecting. Find the pressure of that dry gas, that means the hydrogen gas, if the atmospheric pressure is. All right, so find the pressure of hydrogen gas. That's our unknown. So P sub H2. That's our unknown. That's our X. We know that our P total is equal to the atmospheric pressure. So that's 94.4 kilopascals. Okay. Now, we know we're collecting it over water. So where in the world did I get this number? So whenever you're collecting over water, you can use your water vapor pressure chart, which I provided to you in your course materials. I highly suggest you print that out and keep it in the same place as you keep your periodic table and your polyatomic ion chart. If you don't have access to a printer, you can copy it into your notebook or onto the back of your periodic table somewhere so that you've got those in the same place so we can be using it. Okay, and so this number for the pressure of water vapor, we just look it up on the chart. So hopefully you guys have your chart in front of you. You're looking at it now. I'm looking at mine and I see that we have 22 degrees Celsius and we have 23 degrees Celsius, but I don't have 22.5 degrees Celsius. So what am I going to do? All you have to do there is we know that 22.5 is halfway in between 22 and 23. So if at 22 degrees it's 2.6 and at 23 degrees it's 2.8, we know it's halfway between that. So halfway in between 2.6 and 2.8 is 2.7. So that's going to be my partial pressure for water. Okay, and now we just plug this into our Dalton's law equation and solve for our unknown. Okay, so here's our equation. So the P total is going to be the pressure of hydrogen plus the pressure of water. Our total, 94.4. Our partial of hydrogen, we don't know. That's unknown. But we do know the water from using our chart is 2.7. Sorry, I put 2.72. That's a typo. 2.7. My apologies there. Okay, and then we simply solve for the x. So to get the unknown, we have to do the opposite. So this is saying plus 2.7. So we need to subtract 94.4 minus 2.7 to get our total, which will be 91.7 kilopascals. Okay, and why 91.7? Check out those sig figs. This one has 3, this one has 3, so our final answer needs to have 3. If you don't understand where some of these numbers are coming from, if you need help using your water vapor pressure chart, please get into contact with me and let me help you out. That way you'll be able to complete the independent practice.